this QR code is actually the link to my slides, which are all available online. If this doesn't work, you can come and ask me for the slides later. So this is the title of my talk. So I'm going to be talking a bit about designing web layouts. Let's hope this goes well. My name is Hui Jing, and what's Penang to And I've been playing basketball for more than half my life, and it was actually what kickstarted my web career. Oh, I have emojis. OK, I now do front-end stuff in Singapore, and I like CSS so much that I will write blog posts about it. I also run this little meetup called Talk CSS in Singapore. But we're not here to talk about me. We're here to talk about Bruce Lee. Now, you may be wondering, what on earth does Bruce Lee have to do with web design, man? Did you just fall victim to clickbait? No. This is not a clickbait title. Just stay with me. I'm going to be putting forth some ideas today that I don't expect all of you to agree with, but I do hope you will hear me out. Now, although Bruce Lee is best known for his fighting prowess, he was also a deeply self-reflective man, and philosophy was an inseparable part of his martial arts practice. So content on the web behaves just like water. Rather than trying to wrangle every pixel into place, we need to embrace the fact that content is meant to flow. If you try to make it fixed, like freezing water into ice, it's not going to fit into all the different screens that people are going to be using to view it, right? So the digital age started in the 1940s. Screens became an output device around the 1950s. And before this, we've always used physical media as a means of visual communication, right? We've been writing on all kinds of surfaces. We've been creating art, painting, and sculpture. We even do physical expression, through dance and performance. But an electronic display like this one is a proxy medium. Whatever we see displayed on the screen comes from data encoded as electronic signals. And the heart of an electronic display is light. Light is transient. You cannot touch light. So when it comes to the web, HTML was invented in 1989 by Sir Tim Berners-Lee. The first graphical web browsers were released around 92. CSS was invented by Håkon William Lee in 94 and made into a W3C recommendation by 96. The reason I'm throwing all these dates at you is to remind you that digital is less than 100 years old. The web isn't even 30 yet. It's a millennial. Think about that the next time the web pisses you off. So the web is a really very young medium, the likes of which we've never seen before. But you know what we have seen before? These kinds of layouts, OK? I've had a computer at home since I was a toddler, so I can clearly remember how a dial-up modem sounds like. I remember hit counters. I remember web rings, guest books. I remember ICQ. I remember all of those things. And back in my day, every angsty teenager had their own blog where they would express their innermost thoughts and feelings in a lot more than 140 characters. And the web had just started to take off, so not everybody wanted to create their own websites from scratch. A lot of these blogs were hosted on blogging platforms like Blogspot, LiveJournal, that kind of thing. And you usually just picked a cool theme from a pool of available options. So this was around the time when screen sizes started to get bigger than 640 pixels. And because we can't have extra space lying around doing nothing, we decided that sidebars were a very good idea. So sidebars would contain links to other blogs or sites, maybe your contact information. If you were entrepreneurial, you could chuck an ad or two in there. And by the mid-2000s, screen sizes had continued to grow. So instead of one sidebar, we decided, let's have two. But this particular layout was not easy to achieve. I mean, you could build something like this using HTML tables, but it was the 2000s. CSS floats was the way to go. Not. CSS floats, like HTML tables, were also a hack in that they weren't meant to be used for layouts anyway. But these techniques were all we had at the time to achieve the layouts that we wanted. Now, to master float-based layouts, you needed to know a lot of things. You needed to know clear fixing. You needed to know negative margins. You needed to have good math skills so you could calculate how to get your gaps exactly right. No, this was actually very difficult. But the web was exploding in popularity, and everyone and their cat needed their own website, right? Then Apple made the iPhone, and the world just went nuts. It marked the start of the mobile web, where we had to test for just a few of these devices, right? And Ethan Marcotte coined this particular term called responsive web design in 2010. And we, as web developers, we had to learn how to use media queries to create different layouts at different screen widths. Life became very complicated. By this time, a lot of people just threw their hands up in surrender and outsourced the pain to CSS frameworks. It's very understandable, especially if you're not familiar with CSS, or you're short of time, or you just don't like CSS in general. But frameworks can be quite prescriptive, and that's why we end up with a lot of websites with very similar layouts. So the flavor of the day right now today is this panel-style layout with all your content sectioned up into panes. And 12 columns, almost always 12 columns, because 12 is a magical number. It can be divided by 2, 3, 4, and 6. So many ways we could rearrange the boxes on our page. I sometimes wonder if the original Sesame Street producers were web designers to begin with, because then we also have this. We have rectangles stacked in all different configurations. They can be big rectangles, little rectangles, all kinds of rectangles. I mean, rectangles are great, but the web is mostly rectangles because for the longest time, they were all we had without resorting to extreme measures of hackishness. But when we encounter something completely new like the web, we tend to want to reconcile it with something we're already familiar with. In this case, the closest thing we had to web was print. And yes, there are lots of similarities, but it's not like the similarity between a white pony and a brown pony. It's more like the similarity between a pony and a unicorn with wings. I want to establish a new normal for the web, right? A normal where people don't expect websites to look the same across every browser and device. A normal where we embrace the fluidity of content and work with it instead of against it. A normal where we cede control of our designs to the browsers that render them. As Jen Simmons once said, the hardest part is changing our thinking. The dynamism of the web and the lack of control we have as designers and developers over the final output is something that should become part of this new normal. People access information on the web predominantly through browsers, and yes, we do have a lot of them. But they're largely powered by 4 main layout engines. So we have Blink, Gecko, HTML, and WebKit. With the maturation of web standards, browser support is less unpredictable than before, although each browser still has its quirks. I mean, features are not released all at the same time. But you know what? That's not a big deal. If we accept this as a feature of the web instead of a bug, we've just opened up a lot more web design possibilities. Feature queries are the key to making this particular approach feasible. And support for it is really good. OK, I'm going to just never mind. So there's coverage in over 90% of browsers, including Opera Mobile. In fact, the only browsers that don't support feature queries are Internet Explorer and BlackBerry Mobile. And this is less of a big deal than you think it might be. This is how a feature query looks like. It's a conditional that checks if the browser supports a particular property or not. If it doesn't, the entire block within the @supports rule is just ignored. This means we can start off with a very basic layout that works everywhere. It could be a single column. It could be float-based. You could be just using browser default UI elements, that kind of thing. And then we layer on additional styles based on the features that we want to use. By organizing our code in this manner, the browsers that do not support feature queries or the property that we want to use will still get styled, whilst those that do can get a fresh new look. We're making use of the C in CSS. You can even call it Cascading Web Design. And remember, if this concept takes off, you heard it here first. In this particular example, the layout on the left is what users will see on IE 11. The layout in the middle is what Firefox users will see, because Firefox doesn't really support CSS Shapes yet. But once it does, it will look like the layout on the right, which is what current Chrome users will see. This is actually a live website. And this kind of a web design approach does require a level of familiarity with CSS, but it's not rocket science. It boils down to experience and the willingness to embrace CSS for what it is. With that in mind, let's talk about what we can do for web layouts. So the first thing I want to talk about is Flexbox and Grid. Now, to me, Flexbox and Grid are like Jay-Z and Beyonce. They're great on their own, but together, they're on a different level of awesome. They both operate on what I call a container-child relationship, in that the display property is applied onto a parent container, which then affects the behavior of all the children in that container. So even though Flexbox has been around for a while now, I don't think we've really pushed it to its full potential. You see, Flexbox may not be as straightforward as something like text decoration or color, but that's because Flexbox can do a lot more than those properties. As of 2017, the odds that somebody is using a browser which supports Flexbox is overwhelmingly high. So the most basic use case for Flexbox is centering things. And when I first learned Flexbox, I hadn't fully grasped this concept of box alignment yet. So in order to center things, I would dutifully do justify content center and align item center, because all the blog posts I read said so. I only found out much later that if you only have one Flex child, applying margin auto does exactly the same thing. It blew my mind. And also, let's say we have more than one item. So we're going to have two. And we want to center things because, I don't know, we like to center things. Setting justify content center will align these items along the inline axis, while setting align items center will align them along the block axis. Right. Now, by default, Flexbox will line all of its children in a single line without wrapping. So we can change this behavior by setting flex wrap to wrap, which did absolutely nothing, because wrap only kicks in when the length of the children exceeds that of the container. So let's make this 100%. So this is kind of centered, but there's this irritating space between the two items, and this is because there is a difference between align items and align content. If we set this to align content, it will treat all the children to be as a single block to be centered in a container. Whereas if you use align items, it will align your flex children along flex lines, which is why there was that huge gap. So when it comes to flex children, a key property here is flex. So it's strongly recommended that we use the flex shorthand rather than each of the individual flex longhand properties. The first value is for amount of growth, the second value is for amount of shrinkage, and the third value is the initial width of the child before any free space is distributed. So flex comes with some handy keyword values, as you can see in this table. And if we don't set the flex value on any children, the initial value is the first one, flex initial, which is 0, 1, auto. This implies that your flex child can shrink, but it cannot grow. Another common thing I hear about Flexbox is that it's really hard to create a grid system with Flexbox. The thing is, you could create a grid system with Flexbox, but it's not the best idea to do so, you see, because Flexbox is suited for laying out items in a single dimension where there isn't a relationship between the rows and the columns. Think of it like a daisy chain of flex children, right? So here I have this list of images, nothing styled yet. So once I apply display flex, all the items are laid out, single line, no wrap. So once I turn on flex wrap, they'll revert to their original sizes because now there's no limit to how much space they need to take up. If there's not enough space left in the container, just drop down to the next row. So if I turn, I'm going to turn on the border here so that we can see what's going on with the flex children when I play around with the alignment later. So now instead of the initial behavior of can shrink but cannot grow, we're going to flip it around. I'm going to set it to 1, 0 auto. And then you can see all the flex children sort of expand to take up the width of the entire container. That's fine. And let's also make the width of the children the width of the container. OK, so now we can, we have a lot of options we can play with when it comes to designing the whole layout. I can do something like, where's my cursor? If we set justify content center and align content center, ooh, what's going on? If we set align item center, we get kind of a jagged looking layout. If I turn off the border, you'll see it clearly. And this kind of a layout isn't commonly seen on the web, because I think we're used to the web being regular rectangles. So I'm pretty sure that some people don't like this sort of new age hipster kind of layout. And maybe your designer says, no, I want it regular. We can definitely do that by giving your images a fixed height. So this really looks much neater. But if I set a fixed height on the image, for some of the taller images, like this one, you'll see that the aspect ratio is a bit skewed. So we can actually rectify this by applying an object fit cover, which will actually crop the tops of the taller images. And this actually looks like a pretty good looking layout. It's not a grid, but it still works. Now we can also change the direction of the flex by setting flex direction to column. And then you have to give your parent container a defined height. And once I do this, I have this horizontal scroll thing going on, which, again, we don't see very commonly on the web. I think horizontal scroll used to involve a lot of hacks, so you don't really see this on the web. But it doesn't look that bad. And also, what we can do is, because I changed the direction of the flex, now the justify content and align items properties actually have flipped. So the axis that it affects has changed. So again, this is a kind of a jaggedy style layout, which, if we don't want to have something like this, we can make it regular. So in this case, I'm going to try to make the height of the images fill up the content, the container that it's contained in. So I'm making use of this function called calc. And calc is really useful when it comes to designing layouts, because if you use Flexbox, you'll realize that Flexbox doesn't account for gaps between items. So if I want my images to have some space between it, I'll make use of calc and let the browser calculate the space for me. So now let's set the width of the items to be exactly the same, and then we get something that looks like this, which doesn't look too bad if you ask me. So the two examples that I showed you earlier, they're not hacks. These are native options we have when it comes to designing layouts on the web. So support for calc and object fit, which was two of the properties I used, looks pretty decent. And they will only continue to get better as time goes on, because the evergreen browser model, which updates browsers pretty regularly, I feel is one of the best things to happen to the web. And there's no better proof point for this than CSS Grid. Now, CSS Grid is a feature that was designed specifically for doing layout on the web. And I don't think I'm exaggerating when I say that CSS Grid is going to be revolutionary for web design. Now, what's even more impressive is the way CSS Grid was rolled out. All the major browsers included CSS Grid in their March update earlier this year. And if you look at the stats today, OK, fine. In a short 6 months, more than 70% of web users are using a browser that supports Grid. And by developing Grid behind a flag, browser vendors could ask developers to test the feature, but prevent them from writing production CSS that wasn't fully baked yet. So Jen Simmons said this in her talk at an event apart a couple years ago, that we need to translate ideas instead of transfer them, meaning we can look for ideas, concepts, and inspiration from everywhere, but we have to utilize them in a manner that best suits the medium we're working in. We're going to look at some examples of Grid in a non-web context first. So the grids that we see on the web are usually regular, X number of columns all the way down. But that was pretty much all the web could do for the longest time without, I don't know, hacks or maybe JavaScript. But irregular grids, from a visual standpoint, are way more interesting, which is why I'm really excited that CSS Grid is here, that we too can have irregular grids on the web and utilize them in a way that makes use of the dynamism of how browsers render stuff. So this is the basic premise of how Grid works. You define your grid, and then you place your items inside the grid. You can let the browser do it for you, or you can do it manually. Now, there are a myriad of options for both these actions, which is what makes Grid so powerful and why some people might find it a little intimidating at first. So let's see how Grid works when we let the browser do the placement. And with Grid, we can do all the things that we're used to, except more easily, like this fixed grid here. the repeat function that I'm using comes in really handy, especially if your layout follows a fixed pattern. So in this particular example, I'm telling the browser, hey, give me 5 10M wide columns. That's it. It's fixed, so nothing changes as the viewport size changes. That's fine, because it's a fixed grid. In this example, I'm telling the browser, I want each of my 5 columns to take up an equal number of free space. So because of this, they will shrink and grow as the viewport size changes, and they'll always take up the entire width of the container. Now, this is something that we've never been able to do before with the min-max function. So the min-max function lets me tell the browser that I want to cap the shrink at 10 ems. But if there's enough available space, grow all of my columns equally. So because of this cap, once there isn't enough space to fit 5 columns, the number of columns will actually decrease until everything fits. And I didn't need to write a single media query to get this behavior. So we can also define exactly where we want our items to go on the grid using the grid row and grid column properties. These properties are the respective shorthands for us to refer to a grid item's position. By default, a grid item will occupy 1 grid cell, and we can use the span keyword to sort of define how many grid tracks the item should take up. And we refer to these grid lines using their numerical index, which somehow starts from 1 and not 0. Go figure. And with the manual placement of grid items, there are a lot more interesting things we can do, and one of which is vertical white space. The use of white space is important when it comes to layout design because it serves to balance the layout and bring focus to important content. In the pre-grid era, every HTML element had to be rendered one after another. And to achieve some semblance of vertical white space, we had to use things like, I don't know, spacer GIFs, things like that, other creative hacks. But now, we can place items wherever we want on the grid we define. So think of it like placing pieces on a chessboard based on the grid row and grid column properties of each item. But of course, a cool thing about grid is that there is also this property called the grid template areas, which is great for white space because I can actually define empty cells using the dot notation. So placement of items using the grid template areas property involves telling the item exactly which grid area it needs to go into. So I'm going to shift the 6th shoe into the grid area named F. And I mean, you could name, I'm sure you can come up with better names than A, B, C, D, E, F. I just suck at naming things, OK? Another interesting technique for layout design is the use of overlap, because it breaks our expectation of the regularity of a grid. We don't usually see overlap on the web because it used to involve a lot of tricky positioning rules using absolute positioning or maybe negative margins. Or sometimes designers just cheat. They'll just process everything into a single image and upload that thing. But now, we can actually do this on the web using CSS Grid. So what we can do, OK, so this is a simple example of overlap, just 2 circles behind a header. And the code here has been simplified just to show the placement properties. But to center the text, all I did was apply margin auto onto the text itself. And pseudo elements are treated as children. So the 2 circles here are pseudo elements of the grid container, and they've been explicitly placed to overlap, whilst the text has been placed to overlap the 2 circles. And the placement code here is a lot more intuitive than if you chose to use absolute positioning to place the items. And you don't have to do a lot of complicated math to get the alignment just right, regardless of the size of the browser. It will always, always be centered. Now, one other dimension that we need to keep in mind when designing for the web is feature support for each browser. This will vary depending on your support policy. And a browser that doesn't support grid or feature queries can get a very basic layout that looks like this. Just a simple layout, uses Flexbox. This demo is actually running on IE8, which is nice. But for browsers that do support grid, I can layer on this fancier overlap with vertical white space layout. Designing layouts on the web requires some level of interpolative thinking. Web layouts can and most probably should morph as your viewport size changes. And our job is to make sure that the layout is the most effective in the space in which it has to perform in. Also, there are a lot more media queries available to us than min width and max width. So for this particular example, I'm using this min aspect ratio media query that triggers the fancier overlap only when the aspect ratio is more than 1. Because any narrower than that, my layout breaks, right? So Firefox actually has the best grid inspector tool in any browser, and the team is constantly working on adding more features to make your lives easier when you start using CSS Grid. So to toggle it, you click on this waffle-like icon onto the container in which you have applied display grid. So once you activate it, you're going to see all the grid lines on your element, and you can see exactly where you've placed your items, which is great for troubleshooting. Now, if you're on Nightly, you'll also have a layout panel in your DevTools, which gives you customization options like displaying the line numbers, or if you're using grid area names, it will show you your grid area names. If you're using multiple grids on the same page, you can change the colors of the grid so you don't get confused. So that's grid. Still got other things to cover, one of which is CSS Transforms. Now, although we tend to associate transforms with animations, there's also a case to be made for static transforms when it comes to layout design. Diagonals are a very dynamic visual direction, and when used in layout design, they will create an active composition that implies movement or depth, and such art direction is totally possible on the web today. Like for this example, we can use grid to sort of place the items and use transforms to give it a floating out of the grid look. But it's still fine to present a regular layout on browsers that don't support grid or transforms. So if you're familiar with image editing software like Photoshop, you'll find that a lot of basic image manipulation techniques can now be done in CSS as well. So these are the 4 basic transformations in the 2-dimensional space, and they also apply when it comes to the 3-dimensional space. So there was this article that was published on CSS Tricks last month called The Critical Request. Now, it's a very interesting article about page performance, but what caught my eye was this really pretty header that was actually an image on the actual article. And this image, I felt, definitely could be webified. So for this type of a thing, you have to consider the space in which your design has to perform in. So for narrow screens, maybe no diagonals, right? Just a nice standard layout. But if we have enough space, why not introduce this diagonal dimension? And again, for properties, for browsers that actually don't support transforms or grid, it's fine to just show the standard basic layout for all of them. Because remember, things on the web don't have to look the same all the time. Oops. Now, 3D transforms also make for great visual impact, and the benefit of doing such a design using text in CSS is that it provides much better accessibility than just sticking the text inside an image. So with 3D transforms, we're operating on one more dimension, which is depth. And so there are some additional properties, for example, backface visibility and perspective. The perspective property controls how far an element appears to recede into the horizon, and the smaller the value, the more dramatic the 3D effect. So if I change this from 45 to 5, boom, it kind of recedes much further away. So support for transforms is really good for both 2D and 3D, but you don't have to use transforms if they don't fit your project. It's just good to know that this option exists so you can reach for it when the time comes. Magazine layouts are also chock full of interesting text flow shapes. And maybe we see this a bit more in fashion magazines, but these layouts are not restricted to those types of publications, because this one is from Bloomberg Business Week. Sometimes newspapers will do it. The idea is to let the text flow around something so it's not laid out in a rectangular shape all the time. The CSS module that allows us to do this on the web is called CSS Shapes. So for now, we can only let text flow around shapes and images with the shape outside property. When you apply this property to a floated element, the text will flow on the opposite side of the float. So these are the 4 basic shape functions that we can use to define a shape outline around which we want the text to flow. We have circle, we have ellipse, we have inset, and we have polygon for more creative shapes. So the shape outside actually shares the same property, the same values as the clip path property. So if you will notice for the polygon example, the clip path and the shape outside are using exactly the same polygon function to generate that triangular shape right there. But shapes from images is what makes me really happy. In this case, the image needs to have a transparency, so you want to use a PNG, because the alpha channel is used to compute the shape around which the text should flow. Pixels that fall below the shape image threshold property are ignored, so text can just flow into that shape. So CSS shape outside is one of those properties that fails really well. If a browser doesn't support shape outside, it will just treat it as though you never applied the property at all. It doesn't break. For example, this. This is an example of CSS shapes failing well, because Firefox actually doesn't support CSS shapes yet. But if you check bug number 1040714 on the issue logs, you will notice that the Mozilla team is actually working on supporting this feature. But now, if you do the same thing in a browser that does support CSS shapes, this is what you will see. You should be able to see the text flowing around Bruce Lee and his fists of fury. So Chrome has been supporting CSS shapes for a while now, and their dev tools can actually show you how the shape threshold and shape margin properties are being applied. Now, a large swath of the world use writing systems that flow from left to right, top to bottom, so languages like English and Malay. But writing systems go in all directions. So Chinese and Japanese can be written both vertically and horizontally. Arabic and Hebrew scripts are read from right to left. That's why we have this property, the writing mode property. It's because it's the World Wide Web. But we're all creative people, right? So even though the primary use of writing modes is to correctly present the various writing systems on the web, writing mode can also be used for art direction. Vertical writing is traditionally East Asian for Han characters, which are used in Chinese, Japanese, and Korean. The inline direction is top to bottom, and the text is read from right to left. Now, when it comes to design, we can lay out text in all directions if we so choose. So this example just demonstrates the writing mode properties' different values. So there's vertical RL, which is the one in red, vertical LR in blue, where the text runs from left to right. We can also combine this with transforms. So if we apply a rotate, we can make the text face the other direction, like in the green example. But you may be thinking, how can we use something like this in the context of a Latin-based writing system? One idea is for headers. It might not be the best idea to lay out long chunks of text vertically, because that just makes it hard to read. But for short titles or headers, it might be a good idea to use vertical writing to break up the monotony of a really long page. Another subtle use could be for tags for blog posts, because tags aren't exactly critical to the understanding of the main content, so laying it out vertically doesn't really adversely affect the reading experience. And also, depending on the number of navigation links that you have, perhaps a vertical layout on a narrow screen could be a design option worth considering. Today, CSS actually gives us a lot more creative choices than we had when responsive design first came out in 2010. So Jen Simmons and Rachel Andrew are two people who have done a lot both for developing layout on the web as well as educating the web development community about it. So Rachel Andrew actually has a CSS layout course, which is completely online, and Jen Simmons has a wonderful collection of web layout demos, which I feel you really should check out. Now, speaking of demos, I feel that everybody should build up their own collection of demos, because that is the best way to learn and familiarize yourself with CSS in general. So this is a list of resources related to the things I covered in today's talk. I will share the slides for anybody who's interested. So CSS has been around for 20 years now. And the last time I checked, there were 501 distinct CSS properties. And no, you don't have to know every single one of them. I'm just pointing out that we can achieve a lot more with CSS now than ever before. And because CSS is an integral part of web layout, it's really about combining all these different properties to create designs that are truly web. Thank you for your time. Oh, and it's also now time for lunch. I hope I have entertained you for the past half an hour. Please have a break.